Hi everyone. Today's Leetcode question is largest divisible subset. So here, given a set of distinct positive integer nums, return the largest subset answer such that every pair in the subset divides divides either of the element. Okay. So basically, what we need to return here we need to return a subset of the given array such that each pair formed into the subset or inside the subset, one of the element divides the other element. It can be any one of the element which divides the other. That's it what we need. So one way to make this problem simpler is by thinking that we need a subset of this list such that when the subset is sorted in ascending order, like in this one, it's sorted in ascending order, then all the numbers which are smaller than a particular number in that particular subset divide that number. In other words, if we choose 8 as our number, then all the numbers which are smaller than 8 divide 8, or 8 is divisible by that number. Okay, so you can see here 4, 8 is divisible by 4, 8 is divisible by 2, 8 is divisible by 1, and similarly for 4, 4 is divisible by 2, 2 is divisible by 1, right? So this makes our problem simpler. So first step we need to do here is we will simply sort the nums. Now our nums is sorted, and now we will be going through a recursive approach. So first off, we're gonna need a recursive function, and let's call it fun. Okay, and inside the recursive function we will be needing an index, so we will call the index I, and we will also be needing a number p will be we'll be storing the value of the previous number of our current list. Okay, so initially the previous number is going to be 1 because 1 divides every integer. Okay, so that's the reason we are going to be giving 1 as keeping 1 as the initial value of p. So yeah, hold on, I will be giving a brief of the solution at the end of the video, so don't worry if you don't understand it right now, you'll be getting it. So here we will be needing a p which stands for previous, or I should write previous. Okay, previous. And we need the array nums. Yeah, here. So first thing in the recursive function we need is a end case. So if I is equals to length of nums, that means we have reached the end of the array, so we are going to be returning an empty array. Okay, second thing is going to be we will be declaring a as a empty list, and if our previous element divides our current element, that is if our nums of I is divisible by previous. Okay, if this is sorry, if this is divisible by previous, nums of I is divisible by previous, that means whichever number which we picked in our list, let's suppose we had a list, we have created a list in which our previous number was 2 and we are currently at 4. So if we see that, yeah, 2 divides 4, that means 4 is suitable to come into our list. Okay, so that means we will be, at this case, we will be adding, we will be a is going to be equals to nums of I plus the recursive function which is returned by the arguments I plus 1, and previous is going to be replaced by the current element, because now as you can see we have appended our current element into our current array, so our previous element becomes our current element. Okay, or our current element becomes our previous element. Okay, and nums will be nums. And a second case where we are not looking at 4, we are just simply jumping to 8. Okay, there are going to be cases in which you will be getting more length of array when you skip a particular element. There can be those cases, so we have to be we have to do something for those cases as well. So we will be declaring b here. B will simply jump. The previous value is not going to change for b. Okay, so previous will be previous and nums will be nums. Okay, yeah. And now what do we need to return? We need to return the maximum length of array which among a and b. So a and b both are going to be storing a list or an array, so we will have to return the one which is longer in length. So if, let's say, answer is equals to empty list, right? And if length of a is, I'm sorry, yeah, if length of a is greater than length of b, answer is going to be equals to a, else answer is equals to b, right? So if this satisfies, answer is a, and if it doesn't satisfy, answer is b. And at the end we need to return the one which is maximum, and that is stored in answer. Okay, and here we have to return the recursive function in which I will be 0 and p will be equals to 1. As I told you earlier that 1 can divide all the numbers, that's why 1 we are going to be giving p an initial value of 1 and nums. So I think we are pretty much done here. So let's try and run our solution and see if we get any syntax error or something. So yeah, positional argument follows keyword argument. Okay, so at line number 17, what do we do wrong? Previous is going to be 1. Yeah, so here we just needed to return 0 instead of I equals to 0. Okay, so yeah, now let's see. Okay, nums is not defined. Okay, so I should have written here nums, just a spelling mistake, typing mistake. Now let's see. So yeah, our first two test cases pass. So let's see if we are able to submit this solution. I think we are going to get a time limit exceeded error. Okay, which we are going to be solving using memoization. So yeah, as expected, we have a time limit exceeded, so we will add memoization here. Memoization will reduce our time complexity, and we will be checking if the pair of I comma j. Okay, so if, I'm sorry, it should be if pair of I comma p. As you can see here that I and previous are the only things which are changing here, right? So I comma previous, I and p are only things which change here, and rest of the things are constant, right? So if this pair is inside memo, that means we already have a output for this query. So we'll simply return memo of I comma previous, and same thing we have to do here, memo of I comma previous is equals to answer. and we also need to pass this memo dictionary into our recursive calls also, and we also have to declare a memo here which is going to be an empty list, empty dictionary. Okay, so it's going to be an empty dictionary, and now let's add this test case, and let's see if we are able to pass. Yeah, so you can see here we have passed all the three test cases, which also include this test case. So let's try to submit it. Let's try to submit it. So yeah, here you can see that we have output here. So yeah, so you can see we have solved it. So now right now I'm going to just give you a brief of our code, what we are doing here. This was it, right? I'll just give you a brief of the steps we are doing. So we are going through a recursive approach. Let's suppose we have sorted nums. As you can see, we have sorted nums. So let's suppose we have 1, 2, 4, that's 5, 8, 10, 12. Okay, this is our nums, right? So let's suppose this is our nums. Now in our first query, what are we passing? So in our first query, we are passing our index to be 0 and our previous to be 1. So I'll just write here. So yeah, I'll just no. So here our first our index is 0 comma previous is 1, right? And rest of the things are constants, so we don't need to worry about it, right? And here you will see that we are calling two recursive functions. I mean, we are calling the recursive function two times here. So that means we are making two branches. So the first branch, if we plan to choose, we plan to include the current number into our array. If we plan to include the current index into our array, then our array becomes 12, right? And plus whatever comes in the future, and our next branch is an empty array, and plus the whatever comes in the future, right? And here also we will be making two branches. The first one will include the next number. Okay, so if we have included 12, now we are at index 1, right? Here also we are at index 1. Index is 1. Index is 1, right? So yeah, here the first case will also be the one in which we will be including either, if we have an option to include 5, we will be including 5. So after including 12, we cannot include okay, so I think I just yeah, so it was should be like this, 1 and 2. So I wrote 12 instead. So yeah, one thing we have to get rid of this 2. So now our first element is 2, right? So if we have included sorry, first element is 1, and if we have included 1, now we can check if 2 is suitable, a suitable candidate to be including our array, and that will be check if 1 is or if 2 is divisible by 1. So here we are checking this if num of I is divisible by the previous element, that is 1. So if that is the case, we call for the next recursive function, which will be of checking if we have to next recursive function will be something like if we plan to include the next one. So here if we plan to include 2, then our array will be 1, 2, and if we don't plan it, then if we plan to skip 2, then our array will be 1. And here also same thing happens, if we plan to include 2, our array will be only of 2, If we plan to skip 2, our array will be again an empty array. Okay, similarly these branches will go on forever, for until we reach the last element. So now we come to this element, which is 4, right? After 2 we come to 4, right? So come to this element. Now we check that after including 2 here, the 2 is previous element, right? So if 2 divides 4, we can include 4. So here we will include 4 if we can. So our new array will be 1 2 4, and here we plan to skip our 4 elements. So 4, so our array will again be 1. Sorry, here we plan to skip our element, so our array will be 1 comma 2. And similarly, if here also we plan to skip 1, then skip 4, our array will remain 1, and if we plan to include 4, our array will become 1 and 4. So on, you will see here that some of the queries are, some of the cases, like here our previous element is also 2, okay, and in here also our previous element is 2, right? So these two queries will return the same output, right? Because the previous element is also 2 and I is also 2. So in this way we are gonna make a whole tree, and after making the tree we are gonna be returning the tree which gave us the list which was longest. So yeah, that's what we are planning to do here. I hope you guys understood. Thank you for watching.